Okay, good morning, everyone. We have done up to question number 14, right? So let's take up three more questions today. So I think we will take today's class and the next class tomorrow. We will finish the mensuration hopefully. So 15, let's see. It says the radio bases of two solid metallic cone of same height h. Okay, digest the question properly there. Uh, the radio bases of two solid metallic cones. We have two solid metallic cones, and the property between them is they have the same height h. Let's draw two cones. Another one. All right then. Here, the height is the same in between them. So the height is the same. They have the same height h here, and h. And it says the radii. It's the plural of the radius. The radii of the bases, they are what? X1 and X2. So for the first cone, the radius is X1. Second cone, the radius is X2. So let's make it, this is X1 and this is X2. Okay, let's come to the second sentence. If the two cones are melted together, they're melted together and recast, it is made, okay, this remade into something else, into a cylinder of height h. So we combine these two, we melt them together, and then we form a solid cylinder. We form a solid cylinder like this. And what is given for the solid cylinder? The solid cylinder has a height h. So the solid cylinder, the height is h. And then what is the question one? Let's see. Show that radius of the base of the cylinder. So this has a radius, right? This has a radius. The cone, the solid cylinder, it has a radius. We have to show that the radius of the cylinder is this much. Root over 1 by 3 x1 square plus x2 square. I try to understand the question properly first. Let me repeat again. We have two cones. The two cones have the same height h. Okay, as seen here, two solid metallic cone of the same height h. Their radius are given as their radii, right? Plural. Their radius are given as x1 and x2. They are combined and melted together, and then we recast it. We form into another cylinder. So the cylinder, the height of the cylinder is h. It is given, but we don't know the radius of the base here. Either this one or either this one. We don't know that. And we have to find out how much is the radius of the cylinder. The radius of the cylinder, we have to prove 1 by 3 x1 plus x2 root over. Right. Okay, then let's see. Let's start the solution. Okay, the key here is these two are combined together to make this. That means the volume of these two together, volume of the first cone and volume of the second cone together, it will be equal to the volume of the cylinder right here. So for the first cylinder, radius is given x1 and h. Radius and height is given for the second cylinder x2 and the h, for the cone. And in case of the cylinder, we know that the radius, the height is h, but we don't know the radius. So radius, we are going to put it as r. Now our goal is to find out this r, and the r should be obtained as this one, this value right here. Get it? So you add the volume of these two together, make it equal to the volume of this cylinder right here. First of all, we need to find out the volumes. So mention here for the first cone, radius is how much? X1. Height is how much? H. For the second cone, radius is how much? X2. Height is how much? H. Okay, since these two are melted together and combined into this, you find out the total volume of this cone and this cone. So find out below. Total volume of the two cones. How much is it? V is equal to volume of the first cone and volume of the second cone. What's the formula for volume of the cone? 1 by 3 pi r square h, right? The volume of the cone, the formula is 1 by 3 pi r square h. What about the radius? It will be x1 for the first one, height will be h, right? So this V1, this is the volume of this cone right here. So you put in the value 1 by 3 pi x1 square h. 1 by 3 pi r square h. Instead of r, we are just putting it as x1 square. And instead of h, the height is given as h and the formula also says h, so we are not changing it. What about the second one? It will be the same, right? Except we will change the x1 into x2. This x1 is changed into x2, that's it. The height is the same, so it will remain the same. X2 square h. Sorry, there is a pi missing. What can be taken out as common factor? You take it out. 1 by 3 is can be taken out as common factor. Pi can be taken out as common factor. Ice can also be taken out as common factor. So you take it out 1 by 3 pi and h. What is remaining then? This part is remaining. 1 by 3 is gone, right? Pi is gone from both and h is gone from both. So this part right here, x1 square and x2 square, it will be remaining. Okay, this is the volume of the two cones. The total volume of the two cones we have obtained it so far. Okay, copy up to here. In the next step, we will make the volume of the two equal to volume of the cylinder. Copy up to here. Okay, I'm rubbing up to here. Till here, I'm rubbing it off. Okay. Now you have to remember that this is the volume of these two cones combined together. And now you come to the volume of this cylinder. The volume of the cylinder, in order to find it out, we need the radius and the height. The height is given as h. The radius, we will take it as r. Okay. So mention here for the cylinder, we have to take let r is equal to radius of the cylinder. What is the height? The height is already given as h. Then volume of the cylinder is how much? Volume of cylinder. You know, volume of cylinder is pi r square h, right? Pi r square h. The radius we are taking is as r, the height is given as h. And now what will be equal between these two? These three, what will be equal? The volume of the two coins combined, two cones combined together will be equal to volume of the cylinder, right? So you mention here by equation, volume of two cones is equal to volume of cylinder. Wait a minute. Sorry. Okay, so we have this equation. Volume of two cones is equal to volume of cylinder. Volume of two cone, it is here. This value right here, right? Volume of cylinder is this value right here. You put in the values, then we will have 1 by 3 pi h x1 square plus x2 square. The volume of the two cones is this one. That's why I'm replacing it here. And volume of the cylinder is here, right? Pi r square h. So you just put here pi r square h. And now you have to understand what is our goal. We want to find out the radius. Radius of what? Radius of the cylinder. Radius of the base of the cylinder. That means we need to find out this r, right? Whatever is equal on both sides, you can cancel them out. Pi and h can be cancelled. That means what is remaining then? I'm going to write the right hand side first. In the right hand side, we have r square remaining. And 1 by 3 x1 square plus x2 square is remaining on the left hand side. I just exchange the sides, right? So find out the radius. We will have root over 1 by 3 x1 square plus x2 square. Look, the radius we have obtained it as this, which is what the question wants us to obtain, right? We have to show that the radius of the base is this much, so we have obtained it. Okay, so we have, since we have obtained it, you just say here, and so. Okay, so this solves the question. The only trick was, since this two is recasted as the cylinder, the volume of these two will be equal to volume of cylinder. This equation right here is all you need to understand. Okay. Any questions? Copy here. Copy up to here. Moving on. Next one, 16. So it's a little similar, but let's see what the question says. Let me make it a little bigger. Okay, must be very small when you see it on your phone. Okay. So you can refer the textbook also, since it's nearby you. A solid metallic cylinder and another solid metallic cone. So we have two things now: solid metallic cylinder, solid metallic cone. They have the same height and the same radius. Okay, let's draw it then. We have a solid metallic cylinder like this, and a solid metallic cone. What does they have in common? They have the same height. Same height. Same height. Let's take it as HH. And they have the same radius also. The radius of the base is the same. R here, R here. What does the equation want us to do? Let's see. The two solids are melted together and recast into a cylinder of radius half r. So from these two, we combine these two together, melt it, and then we recast it into a cylinder. Another cylinder, okay? But why am I getting rectangle? Okay. So this new cylinder right here, it has a radius half. The previous radius, the radius of the cylinder and the cone, they had the radius r, right? But for this one, this is not very good looking. So after these two are melted together and then we recast it into a cylinder, we obtain a cylinder of radius half r. Okay, the radius is how much? 1 by 2r for the new cylinder. Okay, now the question wants us to prove that height of the new cylinder is 16 by 3. There is a h in here. If you look at the textbook, there is a h here. So height you have to prove 16 by 3 h. So the height is this much from here to here. Let's make it h prime. Okay, because we took the height as h as given by the question. We don't know the height of the cylinder, this one. We have to prove that this is equal to 16 by 3h. Since h is in the cylinder in the cone previously, let us take h prime as the height of the new cylinder. We have to prove that h prime is equal to how much? 16 by 3h. Get the question? Okay. Now, let's solve it. What will be equal between 1, 2, 3? It's similar as the previous question, right? When you add the volume of these two together, volume of this and volume of these two together, it will be equal to volume of this one. So find the volume of the cylinder, find the volume of the cone. Also find the volume of the new cylinder. We have to add these two together and make it equal to the volume of this one. Okay, let's start. So you have to mention here for the cone and cylinder. Since both of them have the common radius and the common height, we can write it together. That's why I'm putting it together for the cone and cylinder. How much is the radius? How much is the height? Now you find out the total volume. Total volume will be volume of cylinder plus volume of cone. Volume of cylinder is pi r square h. Volume of cone is 1 by 3 pi r square h. Pi r square is pi r square h. We can take it out as common factor. What is remaining in this one? All the pi r square h is gone, so only one is remaining, right? 1 plus. From this one, this portion is gone. That means 1 by 3 is remaining. So we will have 1 by 3. Add these two together, 1 plus 1 by 3. It is the same as expression 1 whole 1 by 3. You multiply and then add this one, right? So 1 whole 1 by 3. 3 ones are 3. You add the 1, we get 4 by 3. 1 plus 1 by 3, it will be the same also. We will have 4 by 3. So finally, we are going to put 4 by 3 pi r square. Okay, we copy up to here. We will come back to the new cylinder later on. Copy up to here first. Now, again, I'm keeping this, the last one. Now, we have found out the volume of these two, right? Come to the volume of this one. And you have to mention here for the new cylinder. Radius is given. How much is the radius? Radius is half r. If you see here, the radius is half r. So you give 1 by 2r. How much is the height? Height we don't know. So we are taking the height to be h prime. So this is not a dash. We say it as h prime. So since the height is what we are taking, we are assuming the height as h prime. You have to say here, let height h equal to h prime. And now you have to fulfill the equation. The volume of these two added together will be equal to the volume of this one. So find out the volume of the new cylinder also. Find out the volume of the new cylinder. Volume of the new cylinder. This will be how much? The usual formula is pi r square h, right? But instead of the r, we have to replace it by half r. Instead of the h, we have to replace it by h prime. So you have to remove this r square and h. You have to put pi first. Then radius will be how much? Half r. whole square into h prime. Okay, don't get confused here, because the volume of a cylinder, it looks like this: pi r square h. Pi is here, pi r square h. Pi is here. Instead of h, we are putting h prime because the new height is h prime, right? And instead of the radius r, we are putting it as half r because it says the radius is half r. Okay. Now you open the bracket, pi into 1 by 4 r square h prime. Look, r square is r square, 2 square is 4, and the 1 square is 1. We just expand the whole square in there in order to get the value in the next thing. Let's keep the constant in the front. Constant means this 1 by 4 in the front. Okay. I'm keeping this value right here. Now you fulfill the equation. The volume of these two combined together equal to volume of this. So you say here volume of total volume. Total volume of what and what? Cylinder and cone is equal to volume of the cylinder. Okay, so total volume of cylinder and cone is here 4 by 3 pi r square h. We've already calculated this, right? And volume of the cylinder is how much? It's right here, 1 by 4 pi r square h prime. So when you put in the value, we will have 4 by 3 pi r square h. Cancel whatever is equal. Pi and pi can be cancelled. R square and r square can be cancelled. We want to obtain the height, right? Height of the new cylinder, which we have taken as h prime. Our goal is to find out this portion right here, this part. Okay, that one we will come back in the next step. For now, you copy up to here first. I'm rubbing off everything. Okay, let's bring it up. So what is left then? We have got 4 by 3 left, h left, 1 by 4 left, h prime left. Let's do a little cross multiplication. 4 and 4 is 16, 3 and 1 is 3. Now we are going to have 16h is equal to 3h prime. What do we want? We want to find out the height of the new cylinder, which we took as h prime. We want this portion actually. So take the 3 to the other side. We will have 16 by 3h is equal to h prime. Right, so it says height of the new cylinder is what now? 16 by 3h, which we have proved. So you say here, hence, okay, you copy up to here and we will move on to the next question. These are easy ones actually. You should look it closely if you follow the proper formulas. It's easy. Okay, moving on, 19. We will do 20, 21 and 22 tomorrow, and we will finish the chapter. So let's see 20 and 19. What does it say? A solid metallic cylinder of radius 14 centimeter and height 21. So first of all, we are given a metallic cylinder. So do a metallic cylinder first. Metallic cylinder. How much is the radius? The radius is 14 centimeter. Height is how much? 21 centimeter. It is melted and recast. So this is melted and recast into a number of spheres. So we don't want the cylinder, we want it in the shape of balls, spheres, right? So we made it into spheres. Why? Okay. So the spheres, they have radius 3.5. Actually, it should be small. I'm just drawing it bigger. Okay. This is melted and form into this. But we are not going to get only one of this. Okay. Just find the number of spheres so far. We made it into small balls, and we have to find out how many number of balls, number of spheres we can obtain from this cylinder right here. We have actually done similar questions in the past. For example, when you have a tank of liter 1000 and you have small bottles which has a capacity of 2 liters. So this big tank has a 1000 liter capacity. The small one has a 2 liter capacity. How many of these small one we can get from this big tank? How many bottles can we get? You have to divide the 1002, right? 1002. You divide them, you get 500. Same thing, we will find out the volume of this. We will find out the volume of this. And then since the question asks how many spheres we can obtain from this cylinder right here, you divide the volume of the two, and then you will obtain the number of spheres. Similar question we have done in the past, if you remember. So you take the cylinder, for the cylinder. How much is the volume? Sorry, you have to mention the radius and height, everything else. Radius is 14, height is 21. So you find out the volume here, volume of the cylinder. What's the formula? Pi r square h, right? So pi is how much? 22 by 7. R is 14 into 14, h is 21. Do not cancel or multiply because we are supposed to divide the volume of this and this. So better keep it here, okay? And come to the radius, come to the sphere. For the sphere, what is the radius given as? Radius is given as 3.5 centimeter. We don't want decimal, so 3.5, if you convert it into fraction, we will have 35 by 10, 7 5s are 35. Sorry. 5 7s are 35, 5 2s are 10. So 3.5, we will convert it into 7 by 2. Find out the volume now. Volume of sphere. 4 by 3 into pi r cube, right? So 4 by 3 into 22 by 7 into r is 7 by 2. You write it 3 times. And now this is supposed to be in centimeter cube. So this will be in centimeter. Centimeter cube here, centimeter cube. Now, when you divide the volume of cylinder and volume of sphere, you will obtain how many spheres we can make from the cylinder. Okay, let's make it. Let it come in the next step. Copy up to here first. Since we want the number of spheres, I already told you all volume of cylinder and volume of sphere. We have to divide them. So, moving this off. So let's mention here when we want to find out the number of sphere is equal to, you have to divide the volume of cylinder and we have to divide volume of sphere. What are the values? We have to divide volume of cylinder is this, volume of sphere is this. So you divide the two is equal to, on this one, we will divide by this one. Now, the reason that I did not cancel anything, even if we could, so 7 and 21, we can cancel it, right? But we did not because we want to uh, cancel the similar ones in the numerator and denominator here. Let's see. So 22 by 7, 22 by 7 can be cancelled out, right? What else? This 2 and this 4 can cancel out. 2 2s are 4. This 2 and these 2 can be cancelled out. And we can cancel out 7 2s are 14. And these 2 and these 2 can be, sorry. Seven to the 14. So again, there is a 7 below 7. There are 3 sevens below, right? So we can cancel each one 7. So let's make it red. 7 2s are 14. 7 3s are 20. What is left then in the denominator? In the denominator, 3 is left, 2 is left. Everything else is gone, right? So what to do then? Sorry, I made a mistake. First of all, let's cancel this and this first. This 22 by 7 and 22 by 7, they are cancelled. Nothing else is remaining. Now time for some cancellation with the 7 and 14, 7 and 14. So 7 2s are 14. 7 2s are 14. 7 3s are 21. You have to be careful here, okay? And then 2 2s are 4. Again, we can cancel out this 2 again. What is left? Look closely. 2 into 2 into 3 is left in the numerator. As you can see, 2 left here, 2 left here, 2 left here. So we will put 2 into 3 divided by. What about the denominator? This 3 hasn't cancelled so far. And this is 1 by 3. Right, and these 3 and these 2, they are remaining. So we will have to put 1 by 3 and 1 by 2. Why am I writing 1 by 3 instead of 3? Because this was the denominator, not above, it is below, right? So 1 by 3, and from here it is 1 by 2. And 1 by 3 and the 1 by 2, how much is it in total? Numerator, 2 2s are 3, 2 2s are 4, 4 3s are 12. 12 divided by 1 by 6. 6 comes up, 12 into 6, it will be 72. So when we find out the number of sphere, the total number of sphere is 70. Okay. Okay, then copy up to here, and then we will finish today's class. We will take up the remaining tomorrow.